we can take any path that we want. So since one of the things that I kind of saw is that a lot of people they're studying a lot of techniques, but then they're finding it difficult to connect with real life problem. So I thought maybe it would be interesting to start with some of this applied thing and and learn some of the models and in the process, you will also learn a lot of machine learning model. So over the next 2 weeks, so next week also there will be a class. So because we have missed 1 week, I'll try to schedule one more class next week, and this is 1 hour. Usually we do 2 hours. So what we'll do today and the next week is recommendation systems, and the underlying models that we will study is very basic kind of models, but we'll also try to cover something which is more interesting next week. So advanced recommendation system will be next week, but this week it will be more about the basic of recommendation system. But even today, what we will do, we will try to pose the recommendation system problem as a dimensional reduction or matrix factorization problem. So in all of machine learning, you will find there are two or three primary directions of machine learning. One direction is what is called as supervised learning, and a lot of are already very well versed with supervised learning. The other part is unsupervised learning, and the third one is semi-supervised learning. In unsupervised learning, usually you will see these concepts of dimensional reduction. And so whatever we will study today actually applies to dimensional reduction as well. So that's kind of the background. So yeah.
Sir, is dimensional reduction is related to features engineering?
It is applied to feature engineering. Feature engineering is one application of it. There are other definitely other kind of application. So this one very so basically like you have usually when you start with machine learning you will see that there is people would say, okay, you have too many features now. And remember last class we studied something which is called curse of dimensionality. That as the number of feature increases, it becomes very hard for machine learning problem to actually learn anything because there are too many features and now one application of dimensional reduction is to reduce the number of features you have. But right now with deep learning and all these things, it is not the most biggest concern because right now we are training with images or we are training with context. So you see that 1 million token or several million tokens size or input as you. So basically the feature set is huge. And since we have a very powerful machine, I don't think it is a big problem to have multiple features or more features. But dimensional reduction, has a different kind of appeal to machine learning, and today we'll try to cover that. Like what is the and as we go to more deep learning models, you will see some of the same concepts will be coming up again and again. But the central piece will remain the same, but how we are modeling it will change. So I'll set the context. So what we're trying to do is basically like, let me share my screen. Yeah, so I think the notes from today's machine are taken from, I think, a Stanford course, which is on recommendation system. I hope you guys can see my screen. Can you see my screen?
Yes, sir.
Yeah. So last week, I mean, this the reason why I kind of also like started thought of doing recommendation system because I think last week I did a guest lecture in SRM University, and I think I covered recommendation system there, and I think this part of it. But I think we will probably go into a bit more different area. But I'll set the problem context first, right? So if you go to any of today's any application that you use, whether it is social media, whether it is YouTube, whether it is Spotify, whether it is Netflix, there are two ways in which you can find items, or what is called, what is, or content, right? So, and we don't even realize, right? When we go to Facebook, we keep scrolling, go to Instagram, we keep scrolling, or we go to news, we keep scrolling. And you will see that the feed or in Facebook, or the news that comes up in your Google News, or the YouTube videos that shows up in your YouTube, are very different from that is in your friend's account, in your parents' accounts and things, right? And the whole reason of having different kind of content for everyone is the goal of recommendation system, right? So why is this, right? So basically, like in traditional, like when all these systems were not there, how would, so suppose like you're looking for a book, right? So what do? You go to library, you search for the book and find it. But the problem with search is that you have to know what you're searching for, right? So that's, I think, the biggest challenge. And since you will never know what all books are, it is not possible for someone to go sit and go through all the books present in library. Just like it's not possible for everyone to go through all the movies in Netflix and then see, right? So previously, what would happen is that people would walk into DVD store, they will find whatever people would like, usually like there will be movies coming out, they will pick that movie. If it's a popular movie, everyone knows about it. They will get to see that. If it is an unpopular movie, they will either to search through it. They have to find which store has it. And search has a problem because you only search for what you know. You can't search for something that you don't know. So in that kind of a world, how do you tell your user that this is something that you might like? So you'll see that all of your whenever you go to e-commerce site, or even like YouTube or any kind of content platform, they will say this is what you might like. And what is why are they interested in what you might like? uh, the whole reason is that so that they can give you a very personalized experience. They can tell you, they can give you information based on what you want to see or what you like to see. And if that they do that, then you then you will come back to the platform again and again, right? If Netflix suddenly gives you unlimited movies, what will happen? You will drop off, right? You will say I'll end my subscription. Or if YouTube doesn't gives you good recommendation of music, you will say, like, okay, I'll probably use some other things. I'll use Spotify or something like that. So all of these companies spend huge amount of resources in trying to figure out what the user want and trying to give the user what they want, so show the user what they want. And uh, and, and it is very core to the business, as I said, right? Because if they don't do it, people will just go away. um, and almost every application that you kind of interact every day is giving you recommendation based on what you like. So the whole point of recommendation system is given a user and given a set of items. And items, by items, I mean something like music, or something like that, or something like movies, or so I'll just first define it. So given a user a given set of items, can you recommend the most relevant items to the user? That is the whole problem of recommendation system. Very simple, right? Given given a particular user, given you have logged in, given I have enough data for you, and given I have a set of items, that means I have a set of, like, I'm Netflix, so I have like I have a set of movies. Can I give you top 10 movies, or top 5 movies, or top 20 movies based on what you like? Right? And even and right now it is much more complex, because in Netflix you will see something which has just appeared, or recent, or popular movies, or you'll see classics. You'll see multiple breakdown of this, but that is secondary. But can you first give the top K kind of uh, items that a user will like? And this is the entire problem, right? And suppose like tomorrow you are building your own website, and what you want is that, okay, you are trying to build your own, suppose music library, or a movie partner. So basically what you want to do is that when user comes to you, you give those from your catalog, you give them the top K movies. So now the question is, how do I, is the problem clear to everyone that what we want to do? Is it clear? Yes, no? Any question on this one?
Yes. Yes.
Okay. If the problem setting is clear, that means we want to recommend items, then two things are very simple, right? So you would think that, so nothing that we are seeing today has not never is new, right? So it has been always thought of, right? It's not, people used to do it in a different way. Now it is done a different way. Like with technology, we get more opportunity or get more leverage, and we do it in a different way or to do it in a better way, right? So then the question is that how people used to do it in previous, like when all these things are not there, when machine learning was not a thing, how people do it? If you think about it, like if you're a business, if you're a grocery store or you're a movie parlor, actually a physical movie parlor store, there are two ways in which you can find the most, or you can get the most relevant things for your user. So one thing that you will say is that, suppose like, like you have created a movie part, you will handpick certain items which you think are very important for everyone, right? So popular movies or movies which are very high rated, so you will handpick. This is called editorial picking. So I was talking to one of my friend. That person is to work for booking, like a traveling company, like booking.com. So what, at one point in time when all these things were not there, they used to actually go and create the list of hotels or list of this places to stay for every city in a manual way. So every week they will update for every city that they serve this list of hotels. They would update it manually that these are the list of hotels, right? So when you log in, you don't get you don't get to see something which is personalized for you, but you get handpicked ones. That means they are well verified, they have good amenities and things like that. So those are called editorial. So a lot of news you will see editorial. People will pick things for you, and then so and the thing is that, yes, even this is very it is effective because it is not irrelevant things. So one idea of recommendation is that how a recommendation is to remove irrelevant things. That means remove low quality or low engaging items. If a movie is low rating, of course no one wants to see it, right? So editorial tries to pick the very best of it and give it. So that's one way to do very recommendation at a very simple way. And you will see that, like previously magazine and newspaper would do this editorial things, where someone would see it, they have very good domain expertise, they will create that list. And the second way to do recommendation system without all this machine learning jaggery is simple aggregation. What is simple aggregation means? If you are not logged into YouTube, that means YouTube has no information about you. Just try it out. Go to incognito mode and load youtube.com and see what videos comes up. You'll see two things comes up. One is that it will change from country to country. Second is that it will be mostly popular videos. So popular or recent or trending videos. So if I have no information about the user, then I can either give them editorial information, or I can give them popular things, or I can give them something which is recent, right, or trending things. So you'll see that in Facebook there's something called trending, and every system today have a trending, so trending item. So in absence of any information of the user, we can always give this kind of recommendation, and this kind of recommendation has been historically very popular, right? Like and that's why like people this is easy to implement. But the problem with this kind of recommendation is they are same for everyone. What is popular for, popular is defined by YouTube, or popular is defined by Netflix. And once you define it, that popularity is not changing for when you log in or when I log in. So the problem with all these things are they're same for every user. So uh, so what these kind of technology companies started to think is that if I have enough data about the user, can I do better than personalized, better than popularity, or better than trending? Because I know what they. So suppose they know that I usually watch thriller movies or thriller TV series. If they know that, then why would they show me a popular movie from romantic or rom com or something like that? right? So there's no way they should show that, right? If they know I don't follow, say, Japanese language, why would they kind of show me, even if it's a very popular, why would they show me, that movie, right? So if I know a specific thing about the user, can I use that uh, to kind of improve this recommendation? Popularity and all these things are fine, but can I even fine tune that? That is what all these thoughts started. Uh, I think someone was telling me that the whole reason why Netflix started recommending this is, and Netflix at the very early stage was like a DVD company. They would start as a DVD company. There was a physical DVD store, and then they would send DVD over email. Oh, sorry, not email, over mail. I mean physical mail, and then so they would show recommendation based on what they have. So they can't show recommendation based on, like, if I'm a movie parlor, I cannot show recommendation based on movies I don't have. Then people will come for the movie and they will not find it. So a lot of things about recommendation that give the user the best item from my whatever catalog I have, right? So even Facebook does it, right? Facebook will like sort the like if you have 10 friends on Facebook, when you log in, the first post you will get is probably from the person that you are most connected with. If it's a friend that you chat a lot, or you have a secret crush on someone, you keep checking their account, and you will basically get that person's post like first, right? Because Facebook can identify that you keep on you keep following that, right? So and the kind of central theme that is coming up is then like what, how do I know that a user likes something? That is, I think, the central theme. And and that's where I think all this feedback comes in. So how do I know that user likes something? So if you go to Netflix, they will see, if you have watched a movie, if you have clicked on a movie, or if you have completed a movie, you completed a TV series. I started a TV series and I left halfway. So even Facebook, like Facebook has click, like, comment, and all these things. That you clicked on a post, they have liked a post, commented on a post, and or you have, you stayed on a post for some time. You read something. Suppose your friend has written a big text on a wall. You stayed and read that, right? So you watched a video. So all these things, YouTube will see if you have watched a video, if you have like halfway through the video, or you like the video, like, comment, and all these things. So, and this is what is called rating, that, the feedback or rating. That means in traditional movie world, it is called rating, because people would watch a movie and then they will rate a movie. They will give, 3.5. You see that today also newspaper publishes these ratings so basically these ratings are feedbacks that users are giving, that I like this movie or I didn't like this. And there are two kinds of feedbacks. One is called explicit feedback. The other is called implicit feedback. And it's very important to understand that how this data, the whole point of data science is that you get more and more signals, and then you use that signal to help your business grow. So you'll see that this interesting thinking that, if uh, like, if suppose, like, you are on Yelp or some restaurant review, the problem is that most of the people will. So just think about it. Like, last 6 months, how many restaurants you have actually gone and eat, dine in, and how many restaurants you have, given a feedback. Unless you're a food blogger, or a active food critic, I don't think you will go and explicitly give feedback. So one of the problems that is recurring in all these existing things is that people don't usually rate, or people don't usually give feedback. They don't usually give ratings or feedback, and that's why explicit rating or explicit feedback is usually missing. Even on Google, like, there are 10 links, and you probably click on one link. So basically you don't give feedback on any of the other links. So then the whole problem is, how do I get more data or signals to understand whether the user likes something or doesn't like something, or something is relevant for them. And this concept of relevant or not relevant will come again and again on machine learning, on recommendation system. The whole concept of relevant is something that is good for you, or something that you like, or something that dislike. There's different way to say this, but relevant is some relevant items are items that from those movie catalog, what movies you will like. And the non-relevant, and even within the relevant, set, you will like something more, you will like something less. So we briefly touch upon in the second class, that this ordering that can exist. Like, I watch two very popular movie. Even within those popular movie, I can have like a kind of a ordering, right? I like Batman more than Spider-Man, like, just for example. So this kind of, so basically, like, coming back to this, this feedback. So all these internet companies are collecting feedback from. And how are they collecting feedback? They're looking at what are users doing, right? They are clicking on it, they're watching a video. So Facebook has this interesting idea that if a person spends a lot of time on a post, that means they like the post, right? So even if you don't like comment, you probably are like, a passive user. That means you don't usually like comment and things like that. So, but like you usually read something or watch a video or watch an image. Like you click on each of the image of your friend, even if you don't like it. A lot of people does. They just click on the image and they will see the photos and they'll just leave it. Facebook will know. So you will not do it for everyone. You will only do it for few people. And Facebook will know that person is better. That person is more relevant to you than any other person, right? So then they will, the next time you log in, they will try to show like those recommendations. Yes, I think Aman, you have a question.
Yes, sir. Could you please tell me that explicit and implicit? So I'm not getting this.
Yeah, so basically, like, explicit feedback is, suppose you went and rated a product, right? For example, you give a rating to a product, or you explicitly left a feedback there saying that this product is good or bad, or you rated a movie or explicitly left a comment on the movie. That is like explicit feedback. That means usually it's a rating. That means you have somehow given a feedback that I liked it or didn't like it, or how much I liked it, right? I gave a rating out of 5. That means how much I liked it, right? So this is like an experience the user has come. So I think people who have joined just now, I'm sorry I didn't saw that a lot of people were waiting. If you are waiting for a long time, I'm sorry for that. I didn't, I know it didn't show me. But I think just to kind of recap, what we're trying to discuss is recommendation system, where we are trying to figure out that given a user, how do you recommend them the most relevant set of movies, songs, or videos as a machine learning problem. We're trying to solve that, and we're trying to discuss like how people usually give feedback. So and what data do we need to do solve such things. So one of the data is that if given a when a video is shown or a news is shown, whether the user liked it or not. And there are two ways in which I can get that feedback. Either the user has went into that news or that video or that whatever movie, right, and they have rated it explicitly, right. You'll see Netflix has this, or any in IMDb you can do that. That ratings are available, right? So you can rate that. Or in restaurants they will give you rating. Facebook doesn't have rating, but you can actually give thumbs up, or you can give reactions, right? Or you can comment is also considered an explicit feedback, but you don't know what they're commenting. So we'll park comment as a separate problem. Is it that that's why sentiment analysis and all these things come, whether the sentiment is positive and negative, and that's where you can actually get a feedback. But explicit feedbacks are those where people have actually gone and took the effort to rate something. Implicit feedback, they have not done that. So instead, like, suppose I have clicked on item, right? Suppose I have clicked on a movie, doesn't mean that I have liked the movie, right? If I clicked on a YouTube video, doesn't mean that I have liked the video. I might not like the video, right? Or there can be something that I've watched. Just because I watched a movie doesn't mean I like the movie, right? So all these things are implicit feedback. That means it is telling you that the user somehow engage with that content, right? That doesn't tell you whether they have liked it or not liked it, but it tells you that they are interested in that, right? So suppose I purchase an item, like these are other videos, purchase, right? Just because I purchased a book doesn't mean that I like that book, right? I might not like the book, right? So, but unless I give that feedback, the system will not know. But if I have purchased something, that means out of all the 10,000 or million books, I have purchased that book. That means that book is I'm definitely interested in that book, right? So these are called implicit feedback. It is not telling you the absolute like or dislike of the person, but it is telling you, I will say not like or dislike. The term that is used technically is called preference. So it's not telling you the absolute preference of the user, but it is telling you that direction that they were interested. It is better than all those things that they have never touched, right? Is that clear?
Yes, sir. Got it.
Okay.
So just like we sometimes we search some books of like machine learning in Amazon. Then related to
Yes.
machine learning topic, they will show many other books of different authors.
Correct. Yeah. Right. So suppose like go to like either e-commerce or like Amazon or kind of any kind of so suppose even in YouTube, right? So suppose you search for a song and then you clicked on certain songs. Um, you might not like those songs, but just because you clicked out of all the songs that are other songs that are there, the YouTube will know that that song was more relevant to you. So that is some more signal. Now, suppose you clicked on a song and you watched, or listened to that song. That is even more feedback, right? Suppose you clicked on a song, you listened, and halfway through you dropped off. YouTube will know that was not relevant because you gave that signal, you didn't complete it. Right? So there are a lot of ways these internet companies will derive the signal, this when they don't have the explicit signal to train the models or to kind of get the feedback. Right. So in the absence of the explicit feedback, you rely on all these things to make sure that you are going in the right direction and giving the right preference to the user.
So did they use clustering method? As you told, it's unsupervised.
We'll come to the method later. We were talking about the problem first. So first, let's talk about the problem. Then let's talk about the solution. Right.
Okay.
Again, like I like as you go more and more into any kind of machine learning problems, the first thing is understanding what the problem is. The second thing is how do I formulate the problem, and the third thing is the method. Method even you have so even if I have suppose like I pose this as a supervised learning problem, I can have 10 models to do it. So first is, can you pose as a supervised learning problem? And if you can, now how do you solve it? So don't go to the, don't jump to the question that, okay, what is the model now? No, no, no. Let's first formulate it as a modeling problem. Then let's go and that's what we studied in the first class. That, okay, given a problem, can I first pose it as a modeling problem? And then if I pose it as a modeling problem, then what is the right model to solve it? Right. So that kind of will help you. So there is one more problem here that we already discussed is for some of the user we will not have this data. Suppose like a new user joined Netflix, they have never used Netflix. Now how does Netflix tell give them some recommendation, right? Or suppose a new movie came, right? You have feedback on old movies or previous movies, but new movie came. How do you now recommend that a new movie? Because a new movie you have no feedback from any user, right? So this is called a cold start problem. We'll not solve the cold start problem right now. We'll assume that we have information for both the user and the items. But usually, if you have a cold start problem, people fall back to the popularity model or to the the trending and all this model. So that's why I said if you log into YouTube as in incognito mode, you will see that YouTube will show you popular or trending videos from your region, from your country. So yeah, so basically, right, that so we will switch gears. We'll switch gears into something interesting. So there are two kind of school of thoughts in recommendation system. So one is very interesting. So let me like give you a very high level picture of all these things. So what we'll do is we'll try to cover this and then what we'll do is that uh, I'll give you pointers to read on this, basically the slides and all these things. But then what you need to do is you need to come back and study more on this and then like come back next week. So I'm just giving you more pointers on this. I'm just opening up a whiteboard. Oh, I think Zoom has a whiteboard. Sorry, I thought Zoom has a whiteboard. Yeah. So let's talk about this in more. So I'll give you the slide so that you guys have access to the slide and all these things. But I'll move away from the slides and try to cover the next part only on whiteboard so that we can cover what we intended to cover. Can you guys see my whiteboard?
Yes, sir.
Okay, great. So yeah, so let me first define the problem. So basically we have a set of user and then we have a set of items. And then we said that, for each user and item, we have some feedback that they got. Again, I'm saying it's a rating, but it can be any kind of video. It can be click, it can be watch, some signal we have. So if you think about this as a problem, then usually it is denoted by a matrix where on the rows you have the set of users. So basically, like you have uh, suppose like I have all the users in YouTube, right? User one, user two, all the way to say user m, right? And then I have suppose I have n items, right? Suppose I have item one, item two, all the way to item n, right? So basically, these are your movies or songs. These are your users, and each user will give some rating to each of the item, right? So, can you tell me what is the nature of this matrix? This is a matrix. Like I hope everyone agrees. This can be, this can be stored as a matrix. But what is the nature of the matrix? Can
So,
we predict? Sorry.
so nature means what?
Yeah, I think someone has commented it's sparse matrix. So the question that I'm looking for is what is so this matrix will have very few columns which have values. So sparse matrix is matrix where most of the columns are zeros. Uh, this matrix is a bit different from sparse matrix though. Here most of the columns are unknown because as a user you will never see all of the items. You will see only a subset of the items, a very small subset of the items, and hence you will have feedback only on a very small subset of the items. Even out of all the video, all the Netflix, or all the videos you have watched, very few of them you have actually clicked. So suppose YouTube have showed you 100 videos, you might have clicked on one. So basically we have feedback on a very small subset of the item for each user, right? So each user has only given, say, out of 1 million video, they have probably only seen 100 videos or given feedback on 1,000 videos at max. So that's, I think, one problem, that this matrix is extremely sparse. That means a lot of cell in this matrix are unknown. Usually sparse matrix means a lot of the cells are zeros, but that's fine. So that's one nature of this matrix. So one so that kind of tells us that, like, a problem here, right? So basically, like, we don't have feedback for a lot of user item pairs. That's one thing. So usually, like, when people kind of thought about this problem, they again thought in two ways, that I can either go as a supervised learning approach, or I can go some other route, right? The most easy part is supervised learning approach, right? So usually what a lot of people would say is that I have, for each user and each item, I have a rating, right? So why can't I train a model with user features, with item features, and the rating as label? The label is rating. Can I do that? Is that possible to do it? Yes, no?
So can you repeat, please?
So so what I want to do, right? So okay, let me first state the problem first. The problem is, given a user an item, I need what their rating is going to be, right? That's my problem. Because if I have the rating, or if I have the whether they will like or not. Suppose I want to predict a score, right? Basically, I want to predict a score. So how would the recommendation system work? So for every user and item, I'll try to predict their score, and then sort the item based on the score and give the top top predicted score, right? So if this is if I'm trying to predict the rating, so I'll try to predict which are the highest rating items, and I'll try to give them, right? So basically, why it's a prediction problem? Because I for a lot of user item pair, I don't have the rating, so I'll predict those ratings. So what I'm saying is that I have user and item and rating data for some set of users. Either it's an explicit feedback or it's implicit feedback. I mean, the implicit feedback, people use click, or they use watch, like as a label. So I can always, given a user and item, I can always find out what they clicked, or they watched, or they purchased, or they completed as a movie, and I can predict that. So I'll pose this as a supervised machine learning problem. I have I have the user, I have the item, and I have the label, and I can predict the label. So once I predict the label, I kind of I can predict whether some probability score that they will like it or they will engage with it. and then I can sort based on the score and give that recommendation. Is that like a viable model? Do you think that's a that's one way to pose this problem?
Yes,
Yes,
sir.
no. Okay. What about others? Okay. So if everyone, so yeah, actually like this is one of the most popular way to do it. That you you pose it a supervised learning problem, and now the question is now if you can pose it a supervised learning problem, we'll park it there. We'll say okay, let's park it right there. Now see what now the question is that how can I get a user feature? How can I get an item feature? So now the problem becomes how do I get the feature? Because the label is pretty much fixed, right? I'll take some feedback and train on that. I can easily convert that to a binary or some categorical label. Even if it's a rating from 1 to 5, I can actually put that label, right? So now the question is how if I have this framework, what are my features? And again, the features are very straightforward. Like if you have signed up for YouTube or signed up for Netflix, they will have a lot of information on your demography, on your like the genre you watch and things like that. Usually, user features are limited in nature. You will have certain user features like the demography and age probably and things like that. Uh, and but the item features are very I would say the item features are very rich, right? So for movie you will have the movie title, you will have the movie description, you will have the average movie rating, you will have the directors, the actors in the movie, you will have what is the genre of the movie, and all these things, right? So that's one thing. So in this problem, one thing that comes up usually is that the user feature is not that rich. I mean, unless you know a lot about the user, unless you're Facebook, which has tons of information of the user, it's very difficult to come up with a user feature. Most of the time, people have a very good item feature, right? So that's one challenge for most of the most of this music recommendation and all these things. Unless a user actually goes and fill up their profile, that's why you'll see in dating apps they will make you feed your profile so that they have most information about you to write give the right kind of recommendation, right? So so that's kind of like one missing piece here. So then how does recommendation system solves it?
Okay,
Sir,
sir.
nowadays we also have the user activity monitoring. So,
Yes, so yeah, so that's so basically what you do is that instead of knowing so usually by user feature we mean that how do we describe the user, right? So one thing that recommendation do is that they represent the user as their activity on the item itself, right? What I mean by that, suppose I have watched 5 movies. I can take the average of those movie feature and I can use that as a user feature. This is one recurring pattern in recommendation system, that the user as a feature is not very enriching. So what I will do is I'll look at what movies they have liked and in the past, and I will post this as a and then I'll create the feature, right? And this is I think one pattern that is usually seen. So that's how like a lot of based on this there are two kind of uh, two I would say two types of recommendation system. One is called a content-based recommendation system. The other one is called a collaborative filtering, right? So what is content-based recommendation system? So suppose like as I say that for the movie, suppose I have the genre of the movie, I have the language, I have actors who actors can be a categorical feature, right? I have director. The number of actors in the whole world is limited, so you can actually pose as an actor, director. So you can create features on the movie, right? So I can create features, and now the user features. Suppose I have the user has watched some K movies, so you can actually average those K movie features and put this as a user feature, right? So suppose like a new movie come up which has similar genre, similar actors, that when you try to match with the user, you will be able to match, right? Yes. Does it make sense? Does this kind of system of recommendation make sense? That you are taking the movie feature. For each user, you are looking at what movies they have watched, then you are averaging that, or you are doing some aggregation over that. And now, when a new movie comes up, you will try to look at the user feature, try to match it with this feature. Because now, since if the movie has similar kind of, similar overlap with previously watched, if they comes from same genre, same actor, same director, or similar actor, similar director, then you will be able to capture it, right? This is called content-based recognition. Basically, why it is content? Because you are looking at what is the content of the item and recommending based on that. Yes, or go ahead.
So my question is like, we are monitoring the user's activity, right? So in that case, how are we required to train the model, as in every case or every time the data is going to be dynamic, right?
Yes.
At every second or everything. Then how to prepare the model for to?
Yeah. So I think, see, let's talk about not the seconds model, but let's talk about even for movies and all these things, even weeks are right. When you don't update your recommendation for a week, you are not going to see much change because the number of movies are not changing that much. What you're saying is we'll definitely do for social media, right? So so that will take us to a different type of machine learning problem, which is that what is the cadence of your training of your machine learning model. You can train, so there are online training, there are offline training, there are different ways. So that is more like the ML ops, that part of it, right? If I train a logistic regression, I can train it once and then use it for the rest of my life, or I can keep updating the logistic regression model, or I can keep on training the logistic regression model on new data. Does it make sense? So there's a whole framework of continuous learning to solve that problem. That okay, how do I keep on updating as the user population changes? So a crude answer to it, that every fixed cadence, like a week or a month, I go either train the model from scratch, or I go and fine tune the model. Some models allow fine tuning from scratch. Some models allow you to find continuously learn. For example, neural networks are one of the example where you can continuously learn. You have some data, you train on the data. Now you have new data, you can. Some of the models don't allow continuous train. So once you have trained the model, you can't train again, right? Most of these exhibitions and all this is you see they don't support continuous learning, and that's one problem, right? So depending on your requirement, so then you have to choose the right model. That whether you do continuous learning or not, you have to choose the right model. So in most of the practical recommendation system, they train from scratch. So basically, like every month or every week, they will just look at last few weeks of data and they will fine tune. In areas where you need every seconds update, you can't train the model so many times, so you have continuous learning up. So your model will look at one sample and it will fine tune, and then you can use the model again, right? So that kind of approach is there. But very good question, yeah. But probably we'll cover this later as well on the ML ops and the design. This is more on the design part of the things. Make sense?
Yes, sir.
Yes, okay, sir.
So one is this. So again, like I'll not go into the details of the content-based recommendation, but you can So I'll share some code, and you can go through that code, and you'll be able to identify the content-based recommendation. Very simple. Like you just have to come up with features. Again, we're not going into the details of how to create the feature. We are just saying that you have to create some features. If you can create the features, then you can either do some aggregation on the user and then match it with the model. Matching can be done through some similarity metrics. What kind of similarity metrics do you think we can use? Any similarity metrics comes to your mind? Cosine, yeah, cosine is yeah, that's a good approach. So we can convert these features into a vector, then we can create cosine similarity, and we can you can have recommendation model. The other way to think about it is that so cosine this is more like. So what is one of the problem here, right? So you are deciding the aggregation. You are deciding whether it's a mean, median, mode, whatever, right? You are deciding the aggregation based on whatever the movies. You are deciding the aggregation. So one way, this type of model I've not found. These are very good to start with. You can very good, effectively build a recommendation system within a day with this, because you don't have to train a model. Just take the feature, average or do some aggregation, and create and put that as a user feature. Now, as the new movie arrives, because the user and the movie feature are the same dimension, if you aggregate, you do the same dimension. The number of feature doesn't change. You're just aggregating. So you can easily cosine similarity and match it, right? So one way then to improve this is, as I was saying, that if you have the user feature, like take this average as a user feature, take some average, like you take the item features and then do some aggregation on top of it. This is my user feature, and then my item features are basically my item features. Here I did some aggregation. Here also I did some aggregation, and then I can have other user features. For example, I can have their gender, their location, and all these things. Other user feature. And finally, I have a label which is the the click or the purchase or watch, something like that. And basically, what I do is that I train a supervised model with that. Usually, people use XGBoost, or you can use Logistic, or even you can use deep learning models and things like that. So this one way. So I create a user feature based on the item feature, some aggregation of it, and now because now you have features, now you can have multiple. Like you can have max, mean, mode. You can have multiple kind of aggregation. So you can have multiple user feature. Now you can have item feature, and now you're creating this label, right? And this straightforward supervised learning, right? You have rating. Now, even if the user has not watched the item or not clicked on the item, you can predict this. And once you predict this, you have a score. So basically you predict it for every user and item, and then for every user you select uh, top k items based on this predicted score. And this is straightforward, because if you are creating click, this is very easy to evaluate. You can use precision recur and all these things to evaluate it. So this is a very straightforward model. So this is the content-based recommendation that I was talking about. I don't think we will have time for collaborative filtering today, but I'll definitely cover it next week. The collaborative filtering approach is two kind. So if you think this one, you are creating this average. You're creating some aggregation, which is saying that this user is connected to those items. So if these are items, item 1, item 2, item 3, and these are their features, basically you are doing the aggregation means you are basically taking their features and doing this, doing the aggregation, some aggregation function you're doing. So that means, can't we say that this user and the items are connected through a graph? Can you say that the user items are connected through a graph? Yes or no? And if they're connected through a graph, what kind of graph is this? Can you tell me what kind of graph this is? So if I have user on one side, right, and suppose I have items on another side. Suppose these are the nodes. So the user will watch or interact with some items, right? And suppose this one. Yes. What is the nature of the graph? So this kind of graph is called a bipartite graph. Yes, it's a bipartite, right? So why is a bipartite graph? Because there cannot be any connection between user and user. There cannot be any connection with the user and movie. So this whole user to action or user interaction with the items is a bipartite graph. It has to connect from the user to the item. And so this tells you that for every user, I have a set of items that they have interacted in the past, right? They have not interacted with all the items. They've interacted with some items, right? So just as a pointer, and this connects both to the dimensional reduction problem and to something that, the traditional collaborative filtering problem, is if I know a user and they have interacted with some items, there are other users who have also interacted with these items, right? Suppose I pick this user, they have interacted with 3 items. See, if I pick these 3 items, I can go to some users who have also interacted with them. Can I say these two these are similar users? depending on how much overlap you. If I have like a watch history and someone has very similar watch history, can I tell that they are similar to me? Yes. So I can go to the item, item nodes, and I can see which are the, so basically I'm finding out the neighbors based on the item nodes. So let's see what are the items. Let's see what are the users who have interacted with the item, which is not the same user. Now, if I have the users who have interacted with the item, they are somewhat similar. So if I have if this user has watched 5 movies, and someone has watched 4 of those 5 movies, they're very similar to this. So I can define a similarity score based on what their watch history overlap is. So each of the other user will get some score or similarity score with this user based on their watch history. Now, if I have some similarity score, I can look at their watch history and I can see what are the things that they have liked previously. And suppose I get all the things that they have liked, but is not watched or not interacted by the current user. So the current user, so there are a set of items, there is overlap, and then there is a set of items that not overlap. And because I can define some sort of scoring or some sort of ordering or some sort of similarity between these users, from their watch history, I can figure out all those items which this user has not watched, and I can I can score those items. So given a user and item, since there is a score, and I'm trying to define a user to user score. So if I have, suppose a score 1 and this is a score 2, what I'm trying to do is that I try to find out all the similar users and look at their item and look at their score and then suggest those items to the first user, which is not already interacted with by the first user. So I'm looking at the movie. So I have watched some movies. I'm finding out all those people who have watched similar movies. There's a lot of overlap. Now I'm going to them and seeing that what have they watched, and then I am recommending from their recommendation. This is called user collaboration. Similarly, we can also do the other way around. We can go from item and figure out which are the users that have interacted with that item, and then we can figure out like like if this and what are the items those users like. So I can also go from this direction to this direction, right? So I can go from the other direction, and that is called item collaboration. So we'll double click on both of these in the next session. I think we are out of time. I'll so this one pointer. I'm giving you one pointer saying that if suppose this is a graph problem, then even if you don't know the content of it, now I'm not dependent on the content. By the way, now I am not saying anything about the actors, the directors, and all these things, right? I'm not dependent on any feature. Just look at this. Like the problem has definition has changed. I have never talked in all of this problem any feature. I just said there is a user, they have watched something or they have liked something, and I can find similar user who have a lot of overlap with that user based on the watch history or just based on their historical engagement. I can figure out, and once I figure out, I can figure out items that they have engaged, but this user has not engaged. So if there is a overlap between what they there is a lot of overlap between what they engage, I can easily recommend the item that is not seen by the user, right? So that is for user. There is an item collaboration as well, and we'll look into more nuts and bolts of it in the next class. The other thing that I want to kind of like give this, and at the end of the day, these two are somewhat related in terms of mathematics. But we'll come to that in next class. So I will give you another kind of pointer, right? So the other point is that I started with this matrix saying that I have m user and I have n items, and there are ratings. There is some of these are missing. There are rating 2, there is rating 3. So similarly, there are some of these ratings are missing, but there are ratings otherwise, right? So there are ratings otherwise. So this is sparse matrix. The other way that I can kind of I will try to point you to is there a way, suppose like I considered all of these as 0, all the missing things as 0. All the missing things I convert them to 0. That means I say that I don't know about those ratings. I will not consider. Can I disregard those ratings? And can I say this, right? So here is what I want to say, right? So this is very fundamental, is that suppose there is a, suppose like this user is like, there are millions of users. Suppose there are, suppose there is 100 million users and there is 1 million items. Suppose this is the ratio. So basically, like, if I look at the, so if I look at the user space, it's a 100-dimensional space, because each user is unique. So if I do try to one hot encode, there would be a vector of 100 million, right? And for user one, the first bit would be 0. For user two, right? So the second bit would be 0. So there's a one hot encoding of 100 million users. Similarly, there is one encoding of this 1 million item, right? So the item and the user space are very, 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 very high dimension, very, very sparse. So one thing that mathematically I can think about, or one thing that I can think about, is that why would a user rate an item? Because they would like some factors. There'll be some genre, some director, some actors. So in this 100 million, direction, or in this 1 million direction, there will be a common space where, through which the user will be related to the item, right? I'll repeat that once more, that the user is 100 dimensional in this dimension, because they have these independent dimensions in nature. If you think about each of the users as independent dimensions, each of the items as independent dimension, there are some dimensions through which they're related. Otherwise, this if they're completely random, it's like everyone is liking that. That is not an assumption. If that was true, then there is no relation. There is no subspace. But there is some space, and that space is often called the latent space. There is a hidden, latent means hidden. So there is a hidden space through which the user is connected to the item. And usually, in the first, in the content, we are saying that this genre, this language, this actor, director are those features. But we are saying that we can't predict all the features. We have only access to some of the features. We can't know all the features. So is there a way in which I can go from this 100 million and 1 million space? I can find a common space. Can I find that? Is there a way to find it without knowing anything about the user and the item? Right? So this is something that is very interesting in nature. And like, I'm just like, giving you one like direction. And next week when we come back, we'll try to answer this question. And this question lies in dimensional reduction problem. Why it lies in dimensional reduction problem is, in dimensional reduction problem, if you think about what we are trying to say, is that each of these, each of these users are represented by their items, each of the what items they have watched. Are there common factors within the item that connect it? Are there common? So if you think about, like, this dimensional reduction problem, always try to reduce the number of features. Why they reduce the number of features? Because some features are repetitive in nature. So if I consider each item as a different feature, so there might be repetitive in nature, because some of these items are very similar in nature, because they are connected through their genre, they're connected through the similar kind of director, actor. So are these spaces where they connect, right? And that way, this this dimension would be much smaller than what we are saying is 1 million, would be much smaller. Can we find that
So
space?
yes, sir. By using the grouping method, we can map the similar
We'll come to
features
the
in
method
other
later. Yeah, we'll come to the method. Let's see what is the method.
and reduce the dimension.
So there's a feedback coming from someone, but yeah, I think definitely we can we can map that. So we'll come to that, how to solve the problem. And I think I tell you the answer. The answer is usually, like, it's called SVD. It's called singular value decomposition. We'll come to this method. And the other one, the grouping one, is more related to the bipartite graph, where you are kind of grouping user and then finding out the item. So that's one way. So we'll look at both of these, and mathematically they are connected. So I'll tell you why they are connected in the next class. So I'll stop here, because we are out of time. What I'll do, I'll send the slides and send some notebook, like a Colab notebook. where you will be able to run some code, like a feature in code. You can create a content and also create like a SVD based. In the next class, we'll try to solidify this approach and then try to solve one problem, and then end with some more theoretical approach to the accounting system, which is done by most now this was done in 2006 2007, what we're discussing right now it has gone to deep learning, and lot of different flavors has come. We will try to touch upon them, but we'll try to first cover these two. But the objective would be to kind of give you a taste of recommendation, the dimension reduction problem as a function of recommendation system. So that's what we try to do. So yeah, so if you have any question and things like that, just feel free to email. I'll try to answer. And also, like, one more thing is that probably like I think a lot of people have set up the time for the one-to-one mentoring, but because of my schedule, I have not been able to attend some of them. I will be opening more slots, and if you have missed, just feel free to sign up. Yeah.